So this is a introduction into section 2.1.2, which is about parabolas, so quadratics. So you guys are going to start with number 11. So I'm going to just kind of read this. It says, what happens to a parabola's graph when you change the numbers in the equation? To get a better sense of the different ways to transform the graph of a parabola as a individual, complete the investigation outlined below. As you work, be sure to sketch the graphs you see in your graphing calculator carefully and record the equation you enter. So for part A, the first thing that you are going to do is graph the equation y equals x minus 2 times x minus 2. And then it says to be sure to label any important points on your graph, including the lowest point on the graph called the vertex. If the graph were to open downward, obviously the vertex would be the highest point on the graph, and then also sketch and write the equation of the line of symmetry. So for number 11, I started that process. So we have y equals x minus 2 times x minus 2. So that would be what the graph looks like. And then the vertex is going to be that lowest point on the graph, which is 2, 0. And then I also did a dashed line at the line of symmetry. So the line of symmetry is what divides the parabola in half. So it's symmetrical about that line. So in this case, the line of symmetry would be x equals 2. So that's all you are going to do for part A. Now for part B, it says to use your graphing calculator to find the equation of two parabolas with graphs that also open upward and still have the vertex at 2, 0. And then you're going to add the sketches of these two graphs on your graph from part A along with their equations. So we're going to go ahead and look at Desmos for this. It's just easier to demonstrate. So what I have is the original equation, which is y equals x minus 2 times x minus 2. Now, we have to keep that same vertex, so we don't really want to mess with that. And think of this as really y equals x minus 2 squared. So we want to keep the same vertex, so I don't want to shift it to the right or to the left, but I still want to have a different equation. So if I did that, that obviously moves it up. That doesn't keep our same vertex. So what I could do is play around with what if I put something in front. So if I put a 2, that keeps the same vertex, it just makes it more narrow. So that's what you're going to be experimenting on. So what you would do is for part B, you would actually write down your equation that you picked and then sketch the graph. So you're going to do that for part B. So you'll have, I would use a different color, so you'll have two graphs for part B. And then for part C, it wants you to experiment with having graphs opening downwards with the same vertex. So for part C, you'll have two equations and two graphs. Part D is asking about, well, what about if I want this particular graph? What would the equation be? And then part E is asking you to choose a new point on the x-axis and find 3 equations of parabolas that touch the x-axis at that same point. So essentially, you're going to pick a new vertex and then come up with 3 equations that all have that same vertex. So that's for number 11. You're actually going to skip number 12, and you're going to go ahead and go to number 13. So for number 13, it's going to have you graph the parabola y equals x squared. And then from there, for A, B, C, D, E, and F, it's going to have you manipulate that equation. So for example, in part A, it asks you, how would we stretch this vertically? And then you would record the equation. Notice it doesn't have you graph here. So you're only doing the original parent graph of y equals x squared, and then you should just have your several equations based on the different scenarios. For number 14, it's going to kind of combine everything that you just learned. So you're going to find a way to change the equation to make the y equals x squared, vertically compressed, open downward, move 6 units up, and move 2 units to the left. And then it asks about the vertex. And that is where you will conclude your classwork. But I am going to do a little bit of just kind of summarizing this. So what I'd like you to do is pause the video now and go ahead and complete 11, 13, and 14. And once you do, go ahead and click play. All right, so you should have paused it. What I'm going to do is just kind of summarize everything that you should have learned from that section. So this, after 14, that you can just write this right underneath it. This is basically our general equation of a parabola. So we're going to talk about each part. So we have the A value. Well, this is the vertical stretch or compression. So if depending on what the A value is, that will determine whether it's a stretch or compression. So if the absolute value of A is greater than 1, we would consider it a stretch. So if we had number like 2, now even if we have like something like -4, that would actually still be considered a stretch by 4. It would just also be reflected, okay? Then we have A values that are between 0 and 1. This would be considered a compression. So think about if you have 1/2, that parabola is going to be wider. So if you were to take your hands and vertically compress it from top to bottom, it's going to squish outwards. Okay, so the other thing we have is we have our H value. So the H is our horizontal translation. So basically that moves right or left. I'm just going to put, and hopefully this will make sense, it always moves in the opposite direction. So for example, if it were to say x plus 3, that would actually move 3 to the left. If it were to say x minus 5, that would be 5 to the right. And lastly, we have K, and K moves up or down. And that one is exactly as is. So if it's +1 on the outside, it moves up 1. And then, so using all of this information, H comma K is going to be your vertex. So this will kind of summarize what you were supposed to get out of this section 2.1.2.